In this video, we're going to be talking about parabolas. Parabolas. I have three examples of parabolas here, and the equation for a parabola follows this form. We have some coefficient a times x squared, and then we add to that another term with a coefficient b times x. And then finally, we add to that our constant term. So, the important thing the important thing for something to be a parabola is that we have this x squared term right here. This is what will make it a parabola, that we're taking our variable and we're squaring it. We can have a parabola without a linear term and without a constant term, but we have to have a squared variable here in order for this to be a parabola. So let's talk about some of the terminology of parabolas. So the first thing that we can notice with a parabola is that parabolas have different direction. And so looking at these three parabolas, we have one parabola that opens up and then two parabolas that open down. So parabolas can open up or down. They can also open to the left and to the right, but for our purposes right now, we're just looking at parabolas that open up, like this example here opens up, or these two examples here, which open down. Opens down. Okay, the next thing that we can talk about with parabolas is that parabolas have a vertex. Every parabola has a vertex. And looking at the parabolas we have here, I'm going to put points where the vertices are. The vertex is either the highest or lowest point on a parabola, depending on whether the parabola opens up or down. So with this example right here, we have a vertex, and that's going to be at our maximum point, and that appears to be at, let's see, 1, 2, 3, negative 3, 3. So that's at the point vertex at the point negative 3, 3. So that's our vertex, and that's the maximum point. That's the greatest value, the greatest y value that we can get out of the function. Looking at this example right here, we have a vertex at 1, 2, 3, 4, 4, and 1. So that's a vertex at the point 4, 1. And we had this was a maximum point on this parabola, but on this parabola, this vertex is obviously the minimum point, the lowest y value that we can have. So a vertex is the lowest or highest point. The lowest or highest point on a parabola. Lowest or highest point on a parabola. On a parabola. And we might be interested in the vertex for a variety of reasons. One place that we see parabolas a lot in the real world is when we throw objects, they track a parabola through space. And so if you wanted to know the highest point that the object was going to reach, then that would be at the vertex. The next thing that I want to talk about with parabolas is the axis of symmetry. Axis of symmetry. So every parabola is mirrored over a certain line, and that line is called the axis of symmetry. And so if we look at this example right here, then it's the parabola is mirrored over this line right here. Let's see if I can draw this. Let's see, I'll draw that a little better. This is the axis of symmetry of this parabola, and it's mirrored on either side of this line. Let me actually continue this a little further down. There we go. So this is the axis of symmetry for this parabola. So I'm going to write that. This is the axis of symmetry for this parabola. And every parabola has an axis of symmetry, and you might notice that the axis of symmetry always goes right through the vertex. So that's the vertex there, and the axis of symmetry is what divides the parabola in half. So to a definition here, the axis of symmetry is the vertical line which divides the parabola, into, we'll say, congruent halves. Into congruent halves would just mean that they're mirror images of, one another. The last thing that I want to talk about with parabolas is that parabolas have intercepts. Now, you might remember when we were talking about linear functions that we were often concerned with our y-intercept and sometimes our x-intercept. And to look at the intercepts for these parabolas here, I'll look at this example here. There are two x-intercepts for this particular parabola. One is right there. Actually, let me do that in a different color so that's a little more clear. Let's do that in red. So we have two intercepts. And the helpful thing about the intercepts of a parabola is that they are always an equal distance from the axis of symmetry. So if I were to draw the axis of symmetry of this parabola, it would be right here. And we'll just pretend that goes right through that tick mark there. And the x-intercepts are going to be an equal distance away from that axis of symmetry. So here we have 1, 2, 3, and then 1, 2, 3. Now, in terms of x-intercepts, a parabola can have two x-intercepts, like in this example here. It can have one x-intercept, like in this example right here. I'll put this little dot in red here just to indicate that that's an intercept right there. And they can also have no x-intercepts, as in this example right here. We're also concerned sometimes with our y-intercepts, and so every parabola is going to have one y-intercept. So this parabola has one y-intercept right there. This is the y-intercept of this parabola, and then this parabola right here crosses the y-axis at this point right here. So intercepts are the points at which the parabola crosses the y-axis. I'll put it down here, the y-axis. And there's always one of those. Or the x-axis. And there can be 0, 1, or 2 x-intercepts.